All right, hello everyone. So I wanted to go through a couple more problems concerning interpreting scatter plots. And looking at number 9, it is asking us from a set of four options to pick which one is the equation of the line of best fit. I'm going to show you a really cool way of going about this without necessarily having to calculate precisely what the line of best fit is, or the equation of the line of best fit. So the first thing that I like to do is identify if the slope of my line is positive or negative. And I notice that my line is going down, it is trending downwards, it has a negative association. And therefore, the slope must be negative. So that allows me to cross out this option because it has a positive slope. In this case, it has a positive slope of 25. So that's definitely out of the running. The next thing I like to do is look at my y-intercept. And looking at my graph, I can approximate that between the two options of 8.5 and 170, it is definitely, definitely closest to 170. So I can easily cross this one out as well. Now, for letters C and D, they both have a negative slope and they both share the same y-intercept. So the differentiating factor here, the only difference between these two is the slope. So now I have to interpret by looking at the graph, or I have to analyze the graph and try to understand which one of these slopes is closest resembling what I'm currently seeing in the graph. And I think the best way to think about it is this. So if we have negative 5 over 8, that means that when I go to the right 8 units, I should be going down 5 units on my y. Okay. So if I look at this, right? So this is y over x. So if I move to the right 8 units, then I should only be going down 5 units, all right, on my y-axis. And I think as we could clearly see, this graph doesn't even extend to 8. But if it did, the line would be somewhere, what is this? 6, maybe 7. It'd be probably roughly somewhere down here. So the difference from the starting point, again, it's every 8 units on the x-axis. So from 0 all the way to 8, that is most definitely a greater drop than just 5 units, okay? So then we're like hesitantly crossing this one out, but I still want to check, okay, does this last one make more logical sense? And so negative 25 written as negative 25 over 1, when I go to the right 1 unit, that means I should be going down 25 units on on my y-axis. So if I go to the right one on my x-axis, then I should be decreasing by 25 on the y-axis. And looking at this, so from this point here to roughly this point here, again, the difference of 1 unit in the x-axis, it is, you could argue, pretty darn close to about 25, okay? If this is 170, midway point here, you could say, I mean, obviously it's not right on the intersection, but it's relatively close to that difference of 25, okay? Or you could even argue it this way. It's much, much more close. That the slope of negative 25 is much closer than the slope of negative 5/8. Okay, so I can eliminate this one. And if I know that one of my answers, if I know that I have to select an answer, right, by sort of process of elimination, then letter D is the most sure choice. Okay, so that's kind of like just a general testing skill, is sort of eliminating the options that do not make sense. And then when you're narrowed it down to two, trying to find the part of the answer that's different. Okay, so in this case, like we said, they both had the same y-intercept, or that b value. So then what we were analyzing was the slope. And we were trying to, you know, interpret which one of those slopes most closely resembled what we saw in the graph. Okay. All right, number 10, it's asking which scatterplot most likely has a line of best fit with the equation 2x plus 1. So again, one of the things I like to do here is I notice that my m value, or my slope, is positive. So I know that if my slope is positive, that means the trend of my points needs to be going upwards. All right. And if I'm looking at letters B and D, you can see that the general trend of those lines, this one is generally trending downward, or I shouldn't say generally, it is trending downward fairly steeply. This one is also trending downward, a little less steep though, a little less steep, okay, but still definitely trending downward. Okay, so now we have to try and differentiate between A and C. And there's a couple different ways you could think about this. You could draw the line of best fit in both of them, okay, and then from that sort of be able to, you know, identify, um, what the slope is of both. Um, Another way that you could do this is just by drawing the trend line, we could identify the steepness of the slopes, and then from that sort of compare them to conclude an answer. All right. So for example, on this one right here, the line of best fit would probably be around something like this. Okay. Roughly around something like that. Now that's not perfect, but it's roughly about where that line of best fit would be. On a problem like this, the line of best fit would probably be around something like here, okay? Again, I'm not doing it precisely, but it's, again, looking at those two graphs, that's roughly where the line of best fits would be, roughly. Now, as I'm looking at these two graphs, I'm looking at A and C, I'm noticing that in A, my y-intercept is really close to the origin, maybe slightly below. And when I'm looking at letter C, I'm noticing that my y-intercept is pretty close to 1. Maybe it's potentially very very slightly below 1, but pretty close to 1. All right. And then as I'm also, so that kind of is analyzing the y-intercept, as I'm also looking at um, these two lines, you could roughly estimate the slope. So for example, I could pick the origin point here and this point here for part A, and I could see that I go up 1, 2, and then to the right, 1, 2, 3. So you could make the argument that the slope is roughly 2/3. Okay, again, roughly. On this graph, if I pick this point and like um, let's say this point here, again, that's kind of roughly where it is. Well, I went up 1, 2, 3, and then I went to the right 2, so 1, 2. All right, let me just actually double check that really quick. 1, 2, 3 over 1, 2. And so that would mean I have a slope of roughly 3 over 2. Okay. Again, which one of these values is closer to positive 2 between these two slopes? Well, this one is, of course, okay? So taking into combination that the y-intercept is much closer to 1 and that the slope is also much closer to 2, then C becomes the natural choice to pick, okay? So again, it was fairly easy to eliminate B and D, but then it took a little bit more effort to try and, again, draw the line of best fit for A and C, and then from there determine which one has a closer, which of those two lines more closely resembles the equation 2x plus 1, okay? All right. And my last one. This is very, very fun problem. So it's asking us to once again identify which one of these equations most resembles or closely resembles the equation of this trend line. Okay. And sort of big glaring red flag for me that I notice is my y-intercept is 0. My y-intercept is 0. In both options B and D, it's giving me a y-intercept of, what is this, 4,000, 1,998. Both of those you can immediately cross out because the y-intercept should be 0, just like we have here, okay? Should be 0. Now, the next thing we have to determine between A and C, well, the only thing different is the slope. it's very tempting to look at the graph and pick this point here and say to yourself, oh, well, up 1, up 2, and then over 1, 2, 3. So therefore it should be letter A. That's very tempting. But if we think about it in context of the problem, okay, we're not saying that every 3 hours my x, or my x in the denominator, we're producing, 2 units. No, we're producing 2,000 units. Okay, we're producing 2,000 units. So in trying to recognize, in context of what the problem is asking. And so the general idea here is that we want to look at the y-axis is saying output in thousands of units. So this isn't 1 unit, this isn't 2 units, this is 1,000 units, this is 2,000 units. So again, we're not saying every 3 years we're only producing 2 units, we're saying every 3 years we're producing 2,000 units. Okay, and what might help, at least kind of for the way my brain works to interpret this, you could even rewrite this. This isn't 1, this is 1,000. This isn't 2, this is 2,000. This isn't 3, this is 3,000, so on and so forth. Okay, so it's critically important that you read, kind of like the phrase, read the fine print. Okay, read the labels and determine, right, what the scale is of the units, what the units are representing. Is it thousands, millions, etc.? Okay, and so then of course we can conclude y equals 2,000 over 3x, and then sort of that hidden invisible plus 0. So anyway, I hope you enjoyed this video, kind of going through different ways of determining solutions without necessarily having to, quote unquote, do all of the work. We're still doing work, but just in a different way of thinking about it. So anyway, thanks for watching. Bye.